can call me Unleash. We are LFX. Back to the studio, Mr. Kings. I greet you. Okay, now we're gonna talk about just one example of these linear differential equations, and we're done for the day. Let's. Okay, watch. The question reads, you can see dy over the x plus 2x plus 1 all over x multiplied by y is equal to exponential negative 2x. So we're going to solve this now. I'll give this solution. Now, from the three steps I gave to you, remember always what the first step. Multiply both sides by the integration factor. What is the integration factor now? Integration factor is simply exponential integral of p of x dx. So you know the general format of all first order linear differential equation. If you've forgotten, let me still show you. Okay. The question should leave us first. Okay. Now let's solve, please. Let's solve. Now we'll have this. So you've seen that the first order linear differential equation has the general formula this. So now p of x from the question, if you compare and contrast, if you could just compare the coefficient of y in the general formula and in the question, you will see that that your p of x is equal to 2x plus 1 all over x, and your q of x is just starting over there. Your q of x is what? Exponential negative 2x. Now we have what we need, so we just have to get our integration factor. So I think it should be v of x will now be exponential integral. What's p of x? P of x is 2x plus 1 all over x dx. So we're gonna simplify the integration factor. So what do? We can split here. Okay, then this will give us exponential integral. If I divide, I'll have here 2 plus 1 over x dx. So if I integrate, I'll have it to become exponential 2x plus ln x. So you can actually see this, right? You can see this right now. I think you should know the law of indices. Look at this now. No, I have here. I can combine it. I have exponential 2x times exponential ln x. No, exponential ln x is just x. So I'll have my integration factor v of x to become x exponential 2x. So with this, I have gotten my integration factor. I can now satisfy the first step, which is multiply both sides with the integration factor. So what do I do now? Have my integration factor. I multiply both sides with the integration factor. So yeah, I have it to become x exponential 2x. This is x exponential 2x. So the question, which is y prime plus 2x plus 1 all over x multiplied by y equal to exponential negative 2x. So I'm going to obey the first step now by multiplying both sides with my integration factor. So if I should do that, I'll have it to become that should be y prime exponent x e 2x plus, if I do that here, this x will clean this denominator here, the x multiply this is a fraction here, so I'll have it to become 2x plus 1 exponential 2x. What else? I think I have y left, equal to exponential negative 2x multiplied by x exponential 2x. You know, if you check the right hand side and see the power, if you are inclined mathematically, you observe that the powers of e, the power of the exponents, if you just add them together, you have 0. So I think here I have it to become y, okay, I can say x exponential 2x y prime plus 2x plus 1 exponential 2x y is equal to, I can now take my like times, I'll have it to become x. So x is just the stuff left. Just x will be the stuff left. So with this, I should figure out the function, which I'm talking about the second step now. The second step is solving linear differential equation. So what do? At the left hand side here, you have to figure out what you should differentiate and have this. So as I've told you, it will always be this. It will always be this. Always. Whenever you want to figure out what should be differentiated to obtain the stuff at the left hand side, it will always be y multiplied by your integration factor. So I think here I'll give us dx of what's our y, or what is just our y. The integration factor is what? X exponential 2x. Okay. So equal to x. We have finished the second step. So the last step is what? Integrate both sides. Integrate both sides. So we're gonna integrate both sides now, and that's the final step to get our answer. So let's do that fast. Now, if I integrate both sides, watch. I'm gonna have this. If I integrate both sides, I'm gonna have this. Okay, so you just ensure that what you have should be this. Now, let's shift this. Continue. Okay, now if I integrate both sides, this hand side, my integral will cancel with this dx here, so I'll have it to be y x exponential 2x is equal to integral of x dx. So I think I have y x exponential 2x is equal to x squared. Can I integrate x? Is it x squared? Okay, over 2 plus c. So whenever you have whenever you try your best by removing the differential coefficient, from the question there is what we call differential coefficient in the question. Now at this part, there's no more anything like the y, the x, or y prime. There's no differential coefficient here. So anytime you get to the differential coefficient, when you try, in fact, the idea of this semester's topic ODE is to give you the techniques, and this is one of the techniques in just removing differential coefficient from a particular equation. So when we are done removing the differential coefficient, so this is what we have left, and I can say we can stop here. Watch more for LFX video. I am Holgate Emmanuel Kinichi, and call me Unleash. Thank you.